So in the previous video, we have seen the definition of transposition, one cycles, and disjoint cycle, and how to write a permutation in cyclic notation. Now here we are going to see how to multiply two cycles with an example. So we are taking an example from S8. So in S8, we consider the following cycles. Cycles, or you can also say permutations. Sigma is equal to 1, 3, 5, 4, 2, 7, 6, and second permutation tau is equal to 2, 3, 6, and the cycle 1, 5, 4, 8. Let us see how to multiply these two cycles. So as I will need sigma tau, so I will write sigma tau here, sigma into tau. So what was sigma? Sigma was 1, 3, 5, 4 into second cycle 2, 7, 6, and tau was 2, 3, 6, 1, 5, 4, 8. Now how to do the multiplication of these two cycles? Again, as usual, you have to multiply from right to left. So you have to take any element from the rightmost cycle and start with that element. So in the rightmost cycle, take any element. Let us take 1 and see where 1 is mapping. So what do you observe? You observe that here 1 maps to 5. Now what you have to do, that in the next cycle, that is in the cycle 2, 3, 6, you have to see the image of this 5. So now come to next cycle 2, 3, 6, but it does not contain five. So as 5 is not there in this cycle, what is the meaning of this? That 5 is fixed by this cycle. The meaning is 5 maps to itself. Now come to the next cycle. Two, 7, 6. In this cycle also 5 maps to 5 because 5 is not present there. And now come to the last cycle. So what do you observe in the last cycle? 1, 3, 5, 4. That 5 is mapping to 4. So far what we have observed, that in the rightmost cycle 1, 5, 4, 8, 1 is mapping to 5. Then in the next cycle 2, 3, 6, 5 is mapping to itself. Again in the next cycle 2, 7, 6, 5 is not there, so 5 is fixed. And in the last cycle 1, 3, 5, 4, you observe that 5 maps to 4. So what is the conclusion finally? That 1 maps to 4 in the multiplication sigma tau. Now next we have to see the image of 4 throughout all the cycles. So again we will start with the rightmost cycle. So see the image of 4 in the rightmost cycle, that is in the cycle 1, 5, 4, 8. So here you can see that 4 maps to 8, so 4 goes to 8. Now see the image of 8 in the next cycle, which is 2, 3, 6. So you observe that 8 is not there in this cycle, so 8 maps to itself. Similarly, in the cycle 2, 7, 6, 8 is not there, so 8 maps to itself. And finally, in the last cycle also, 1, 3, 5, 4, 8 is not present. So again 8 maps to itself. So what we conclude that 4 maps to 8 in the permutation sigma tau. Okay, so we have found that 1 goes to 4 and 4 goes to 8. Now we will see the image of 8 in sigma tau. So start with the rightmost cycle again. So what we observe that 1, 5, 4, 8 in the cycle 1, 5, 4, 8, 8 goes to 1. Then in the next cycle 1 is not there, 1 is fixed. Again in the next cycle 2, 7, 6, 1 is fixed. And in the last cycle 1, 3, 5, 4, 1 is mapping to 3. So what is the conclusion? That 8 maps to 3. So what we have got, 1 maps to 4, 4 maps to 8, 8 maps to 3. Now we will see the image of 3. So start with 3 and start with the rightmost cycle. 1, 5, 4, 8. Here 3 is not present, 3 is fixed by this cycle. In the next cycle 2, 3, 6. You observe that image of 3 is 6. 3 maps to 6. In the next cycle 2, 7, 6. You can observe that 6 maps to 2, so 6 goes to 2. And in the last cycle you see the image of 2, where 2 is not present, so 2 is fixed. So hence we get that 3 maps to 2. So 1 goes to 4, 4 goes to 8, 8 goes to 3, and 3 goes to 2. Now we have to see the image of 2. Start again with the rightmost cycle. 2 is fixed. In the cycle 2, 3, 6, 2 goes to 3. In the cycle 2, 7, 6, 3 is not present, so 3 is fixed. And in the cycle 1, 3, 5, 4, 3 goes to 5. So therefore 2 goes to 5. So 1 mapping to 4, 4 mapping to 8, 8 mapping to 3, 3 mapping to 2, and 2 is mapping to 5. Now let us see the image of 5. In the rightmost cycle, you observe that 5 maps to 4, 5 goes to 4. Here 4 is not present, 4 is fixed. Here also 4 is not present, 4 maps to 4. And in the last cycle 1, 3, 5, 4, 4 maps to 1. So you again came back to 1. 1 goes to 4, 4 goes to 8, 8 goes to 3, 3 goes to 2, 2 goes to 5, and 5 is going to 1. So far what we have observed, hence we got here that 1 is mapping to 4, 4 is mapping to 8, 8 is mapping to 3, 3 is mapping to 2, 2 is mapping to 5, and 5 is again going back to 8. 1. Now which number has left out here? The numbers 6 and 7 have been left out. So let us see the image of 6 and 7 also. So we will start with 6 and start with the rightmost cycle. 1, 5, 4, 8. Here 6 is not present, so 6 is fixed. 2, 2, 3, 6. 6 goes to 2, so 6 is mapping to 2. In the cycle 2, 7, 6, 2 goes to 7, so 2 will map to 7. And in the last cycle 1, 3, 5, 4, 7 is not present, so 7 is fixed, and therefore 6 maps to 7. Finally, we will see the image of 7. 1, 5, 4, 8, 7 is not present, fixed. 2, 3, 6, 7 is not present, so fixed. 2, 7, 6. Here you see that 7 goes to 6, so 7 will map to 6. And the last cycle, you have to see the image of 6 here, so 6 is not present, so 6 is fixed. So we observe that 7 goes to 6. So the next cycle which we get in sigma tau is 6, 7. So here we see that we have exhausted all the elements from the set 1, 2, 3, 4, 5, 6, 7, 8, and hence multiplication of sigma tau is the first cycle 1, 4, 8, 3, 2, 5, and again 5 goes back to 1, so close the cycle. And the second cycle is transposition 6, 7.